So what we're looking at in this lesson is how to describe the trend on a line graph. A line graph, as you've seen in the previous lesson, is showing you how a change in one variable affects the second variable. So it's looking at how the independent variable, what you're putting on the x-axis, affects a particular factor, and you're measuring something to see that change. So what you're measuring is your dependent variable, which is what you're putting on the y-axis. The names of the variables are always shown on the axis of the line graph if it's a question where you need to describe. The scale reading on the x-axis increases as you move to the right. So as you're going from left to right here, the independent variable is increasing there. And the scale reading on the y-axis increases as you move upwards. So for the dependent variable, we're going from smaller to larger that way. And the shape of the line graph allows you to describe the relationship or trend between those two variables. And there is basically only three possible trends that can happen. Either as your independent variable is increasing, so is your dependent variable, and you'd see a line that looks like that. Or as your independent variable increases, your dependent variable stays the same, you'd see a flat line. Or as your independent variable is increasing, your dependent variable would decrease, and you'd see a line going down the way like that. So it's quite straightforward. So if we have a look at some examples. So we've got an example here of an experiment that's looking at how temperature is affecting the rate of reaction. So temperature is our independent variable on the x-axis there, and then the rate of the reaction is our dependent variable on the y-axis. Now when you're describing a graph, you must make sure that you mention both variables and always start with the x-axis. It's a bit like reading a book. You always read from left to right. On a graph, you always start with the x-axis and then mention the y. So x before y in the alphabet, x before y when you're describing a graph. So for this particular graph here, you can see that as the temperature is increasing on the x-axis there, we've got an increasing rate of reaction. So we've got that upward trend there, and that's all you need to be putting to get the mark there. So as the temperature increases, the rate of the reaction increases. Never use the word it. I've seen students lose marks on this all the time. You need to specify what it is, what you're talking about. So don't ever do it, ever. We've got another example here, and we've got an experiment where they're looking at the speed of an object over time. So it's slightly different. In this case, we've got a decreasing line here. So again, starting with the x-axis, you can see that as the time is increasing, the speed here is decreasing. And again, that's all you need to be putting to get your mark there. So as time increases, the speed decreases. It's going down. This one here, it's a slight bit more tricky because there's a change point. It's not, going just in one direction. We've got a little bit of a change that's occurring here. You must make sure that you just describe both parts separately, so don't panic. It is dead straightforward. You just need to make sure that you're mentioning both parts. So you can see here, as the light intensity is increasing in that first bit, the oxygen production is also increasing. Then, after a particular point, as the light intensity is increasing, the oxygen production remains exactly the same. Now that would probably get you 1 mark here. Usually this sort of graph here is worth 2 marks, because what they're wanting is they're wanting you to explain or detail what the change point is. Okay, so to get your full marks, you must mention the change point. So have a look at the weighting of the question. It's usually worth 2 marks, and often you'll get 1 mark for saying the pattern that you've got on the graph. So as light intensity is increasing, the oxygen production increases and then stays the same. And then your second mark is for saying at what point that change point happens. So at 40 lux. So if you'd said as the light intensity increases to 40 lux, the oxygen production increases. Then after 40 lux, the oxygen production stays the same. You've got 1 mark there for the pattern that you're describing, and then 1 mark there for correctly identifying the change point. Make sure that you are super accurate when you're mentioning the change point. Don't, some people have a tendency of rounding down or rounding up to the nearest number, like, oh, it's like the change point's happening at, let's not say 40, let's say it's happening at 44 lux on the graph, and they're like, oh, it's happening at about 40. About 40 is not going to get you the mark. You have to be really, really precise. So read off the scale nice and precisely. So we've got a little graph here. It's a little bit more complicated, and hopefully you can see there is a change point. So again, you're going to get your marks for describing the trend and then describing the change point. So we can see here, before this change point, we've got a decreasing dependent variable. After the change point, we've got an increase in the dependent variable. So for your marks here, you can see that as the pH increases, the time taken for the solution to clear decreases. Then as the pH increases above 8.5, the time taken for the solution to clear increases. So again, you've got 1 mark for saying that, the pattern is that as the pH is increasing, the time taken for the solution to clear is decreasing and then increasing. And then your second mark is for correctly identifying that change is occurring around pH 8.5. So just always make sure that you're describing the pattern fully and the change point, because there's loads of different ways that you might have worded that. But as long as you've mentioned the pattern fully, so you've not just said that it's increasing, you've actually said that it's decreasing, then increasing, and then mention the change point, you should get full marks. So this is a little graph question that I've pulled up. I think it was from about 2 years ago, and I had an awful lot of students who did not get the mark here for this particular graph, and it was mainly because they had not correctly identified the full pattern here. Lots of pupils that I had taught when they were describing this graph here, they simply said that as the distance from the seawater at low tide increased, the average number of lugworms increased, and that's not true at all. You can see there's quite a clear change point here. Okay, so all along this part here, okay, we've got an increase. At this point here, we're staying the same. So again, you can see it's a 2 mark question. We're going to get 1 mark for the description of the trend. We're going to get another mark for the change point. So for this particular chart here, again, reading from the X first and then up the Y, as the distance from the seawater at low tide increases, so does the average number of lugworms, or as the distance from the seawater at low tide increases, the average number of lugworms increases. Then they needed to say at a distance of 12 metres, the average number of lugworms stayed the same. So that's all they needed to put for 2 marks. So as the distance from the seawater increases from 0 to 12 metres, the average number of lugworms increases. After 12 metres, the number of lugworms remains constant. So again, 1 mark for describing the general trend, another mark for correctly identifying the change point that is occurring. So it's nice and straightforward, and just like usual, what I'd quite like you to have a go at is I've pulled out a selection of questions to do with describing trends, not necessarily just on line graphs. Sometimes it's describing a trend within a table, and I'd like you to have a go at those. Good luck.